Let's go. What's up, everybody? Welcome to the Comet ML Office Hours. Today, we are on the third video of the series on standardizing the experiment. I'm excited to be here today. We're going to do a quick lecture type of format, followed by a very special guest that's joining us today, Dr. Angelica Lo Duca. And I'm excited to chat with her. If at any point you have questions, feel free to drop the questions right there in the chat if you're in the Zoom room, or if you're watching on LinkedIn, feel free to drop questions in the comment section of the video. We will be monitoring the stream there and taking care of all of those questions. So let's go ahead and get right into it, my friends. So let me go ahead and pull up the video here. Sorry, the slides, and we'll go ahead and get started. All right. So today we are going to be talking about how to tell if you've built a good machine learning model. So far in the series, we've talked about how to clearly define a problem statement. We've talked about how to scope it out. We've talked about how important defining the task and evaluation metrics are. And I know what you're thinking. Fudge yeah, data lover, let's do this. But hold up just 1 second, though. I know how tempted you are to start throwing all the data at all the algorithms, but I'm going to warn you, just that's a recipe for endless suffering. Yes, that's right. Endless suffering. Horrendous suffering, in fact. And today we're going to talk about how we can alleviate some of that suffering by establishing baselines. So in the enterprise, it's almost always the case that the problem you're working on is unique to your use case, your data, and your definition of what good performance is. Unless there's a company who has the exact same business model, customers, products, etc., as you do, then there can't be a universal definition of what a good model looks like or what good performance is defined by. So the question you ask yourself is, okay, well then, how am I supposed to know if my model is any good, or if machine learning is even the right approach for solving this particular problem? And that's where your domain knowledge and experience come in, because that will undoubtedly provide you with enough intuition to formulate some hypotheses as to what type of performance you might be able to achieve. But unless you're working with a benchmark data set, you won't know if the performance that you see is something that you can actually achieve or just some fantasy. Or rather, not the performance that you see, but the performance that you are hoping to achieve is something you could actually do or some fantasy. So it's helpful to think of model performance as being relative. So how good a model performs only makes sense in terms of its performance relative to another model trained on the same data. So that's why it's helpful to have a meaningful reference point for comparison. And that reference point is what we call a baseline. So the baseline model serves the purpose of providing a point of comparison against any advanced or altogether different methods that we might choose to experiment with. So as a legendary Jason Brownlee highlights many times on his machine learning mastery blog, if you haven't checked that out, hands down my favorite blog. I love that guy. So there's really three characteristics of a baseline model. One, it's simple. It's going to require little or no training or intelligence. It's fast. So the method is fast to implement and computationally trivial to make a prediction. And it's repeatable. The method is deterministic, meaning that it produces an expected output whenever you're given the same input. So if you want to play with fun toys and start with the complex model, let me preface this by saying this is a quote by Emmanuel Amison, who's also written an amazing blog on baselines. But what he says is, if you want to play with fun toys, start with the complex model. If you want to solve problems and build products, start with the stupid one. And finding a baseline really is as complicated as you would like it to be. You could start simple, though. For example, you could build a model that uses business logic or some bureaucratic heuristics to make a prediction. You could build a trivial model that would produce a random result. such as like the most, commonly occurring value, or you can have something be as simple as the average value. These are perfectly reasonable baselines for systems that are not too complex. But depending on the type of problem you're working on, a simple model won't serve as a meaningful or useful baseline. And for those situations, we have at least 4 other ways to establish a baseline. So in his course, Introduction to Machine Learning in Production, Andrew Ng suggests using one of the 4 as a baseline. Human level performance, that is a oracle. You can query a human that could provide an answer. You can use literature, state-of-the-art, or open source solutions. You can do a quick and dirty implementation, or you can use the performance of an older system. The point that Andrew is making is that the purpose of these baselines is to give you a sense of what's possible. They give you a sense of the lower bound of the irreducible error. And to quote Andrew Ng here, in other words, what is the best that anyone could possibly hope for in terms of performance on this problem? That's what we mean by the lower bound for irreducible error. So let's run through a thought experiment. So suppose you're working to deploy a model that will classify the department an email should be automatically routed to when a customer sends an email to your support desk. You want to run an experiment to see if machine learning solutions will be useful for your problem. The first thing you got to do is state a hypothesis. For example, optimizing performance metric X has a positive impact on the KPIs that we care about, right? That's the hypothesis that we state. You can then conduct an experiment by deploying 2 models, maybe a heuristics-based approach where you just simply scan an email for certain keywords, or a human or oracle on the production data, like a human in the loop, but then don't actually serve the prediction. So you do this in shadow mode. The predictions don't be deployed, you're not using them. And the key point of this exercise is to help you understand how your model's predictions affect the KPIs that you care about. So at this point, what are some questions you should be asking once you deploy this simple baseline? What is model performance? What is model performance metric when you're using the heuristic? How close does that heuristic get us to your KPI goal? And is that gap big enough that we can justify using machine learning to make up the difference? How close must our model performance be to our oracle or human in the loop performance in order to positively affect our KPI? And then for cases where an oracle can provide a gold standard answer, if the oracle is unable to affect our KPI, do we need to change our approach? Do we need to rethink the target variable that we're trying to predict? Do we need to change how our model interacts with the rest of the system or with our users? These are just some questions that you should be asking at this point. So after thinking about these questions and conducting the experiment, suppose that we observe our simple baseline heuristic predicts with a 65% accuracy. And that 65% accuracy translates into a 2% increase in our KPI. And since our human oracle knows their stuff, they're able to predict with a 100% accuracy. And then we can say, okay, that 100% accuracy translates to a 10% increase in our KPI, right? Well, that's good. We've got a reason now to believe that increasing model accuracy will positively affect our KPI. And we've got a preliminary baseline result. Note that it's a-okay if your attempts at establishing a baseline results in a crappy evaluation metrics. That just means you've got a hard problem, a tough problem on your hands. And that leaves plenty of room for experimentation and improvement. What does matter is not being able to do better than the baseline. If you can't beat your baseline, you might have a problem that is intractable. You might need more data or just completely different data altogether. For example, in our thought experiment, it becomes now our responsibility to find a model that's accurate more than 65% of the time and produces at least a 2% positive impact on our KPI. And this is where you will start running some experiment. What are you going to experiment with? You can add or change the features. You could test various algorithms. You could start with simple ones and move on to more complex ones. You can experiment with the parameters of your algorithm. Just experiment as much as you need. Just be sure to track each experiment along with your chosen evaluation metric, the algorithm, its hyperparameters, and the model architecture. Because it's an iterative process, you've got freedom to explore a wide range of hypotheses, but you still want to be able to make sure that you're tracking your experiments consistently, coherently. And this process will help you determine whether your efforts are getting you any closer to a better performing model. So the experimental part of machine learning is, in my opinion, the most fun and creative aspect of it. Trying to find the best model for a given problem, it can be daunting, and it is definitely a challenging task. It could quickly become a messy process of trying a variety of different algorithms, losing track of the process, and not remembering what features or architectures or embeddings work best. And that's where a tool like Comet becomes invaluable, because it helps you track all of the experiments you're running so you can focus on building the best model for your use case. So that was just a quick primer. I'm just talking quickly about baselines. For those of you who have registered for the course, which is entirely free, by the way, if you've registered for the course, you're getting links to blog posts that talk about this in a little bit more depth. You also get links to some of the behind the scenes work where you can see this done in action by my colleagues, Drew and Michael. Amazing to get exposed to the concepts and the practices and then see it employed, see it done. So you'll be getting links to those as part of the email as well. And also speaking with industry practitioners to talk about how they work on stuff. So before we bring on our special guest, I just want to check and make sure if anybody has questions. So if you got questions, feel free to drop them in the chat or drop them in the comment section on LinkedIn, wherever you are. I'd be happy to take on those questions. So it does not look like we have any questions coming in. All right. So we'll go ahead now and let me introduce our guest. Now go ahead and we'll bring her on and we'll have a great discussion with her. I've got a few questions queued up, and by all means, if you have questions lingering from the beginning part of the series, feel free to ask. You can ask them at any point. We'll address them once we get to the Q&A section. During our discussion with our guest, if you've got questions, feel free to drop them in the chat or in the comment section. We'll be happy to take them. So without further ado, let me introduce our guest. Our guest today is a PhD computer scientist with experience in the fields of data science and web application. She's a professor at the University of Pisa, where she teaches data journalism. Her other research interests include data science, machine learning, text analytics, data visualization, data journalism, and web applications. She's an active learner who loves to share and teach what she learns, and has had her work published in Towards Data Science, The Data-Driven Investor, KD Nuggets, and also Comet's in-house publication. She's also a multiple time top writer on Medium as well. Please help me in welcoming our guest today, Dr. Angelica Lo Duca. Angelica, how are you doing? Let me go ahead and unmute you there.
Okay. Can you hear me? Yes.
Yeah.
Hi,
yeah,
everybody. I'm very glad to be here today with you. And I follow you and I like your seminars very much. Congratulations. I'm here.
Thank you very much. No, I appreciate you taking time out of your schedule to join us. And I've been a fan of the work that you've been publishing on Medium. I've been able to catch glimpses of that recently. Where are you joining us from?
Sorry, I'm from Italy. I'm
Nice.
a researcher in Italy, yes.
Awesome. And in Italy, before we get into the machine learning process, I want to learn more about this awesome stuff you're doing at your university, data journalism. This is
Yes.
something that I'm not very familiar with. So if you don't mind, what is data journalism and how is that different from data science?
Yes, is a journalism based, driven by data. And you have the main purpose of data journalism is to build stories on the basis extracted from the analysis, data exploration, and so on. And so we can say that there is a very difference between science, firstly in their purpose. Because as that science aims firstly at extracting some insights from data in order to make some decisions. In data journalism task, instead, the main objective is to build a story. And so also the target audience is different in the two cases. Maybe in a journalism, in a data science project, the main audience is your boss, a company, or the customer, or while in a data journalism project, the audience, the target audience is the reader who reads a magazine, a blog, or something else. And so you have to build also your project with a focus on your target audience. And so also the final results produced by your project is different because in the journalism, the final outcome should be a story. In a data science, instead, maybe you have to produce a report with helps your boss of the company to make some decisions. There are also other differences between the two fields, but I think that here there is
A project?
yes, there is indeed you can follow the same steps of a machine learning of a data science project in data journalism, but usually in a data journalism project, there is not enough time, but if you want, you can ask in the chat. If you want to know other things, you can ask in the chat, and I will be happy to answer.
I guess the life cycle for data journalism type of a process, is that a different kind of project life cycle from a traditional machine learning?
That analysis part is missing because you don't have to analyze something. You have only to explore data to extract some stories. But if you want, you can also build a machine learning model, maybe to predict something in the future. You can, but it's not mandatory.
So I think a lot of people might be working on projects which are maybe personal portfolio projects or projects that are used to develop their own knowledge or understanding of a topic. Before we get into more about reproducibility and things like that, I found it interesting that you had this blog post where you talk about how we can translate projects into interesting scientific papers. So can you talk to us a little bit about that? How can we translate some of our projects that we're working on the side, or maybe even projects that we're working on at work into a scientific paper?
Yeah, I am a researcher. Thus, for me, it's natural to translate a project into a scientific paper. However, I can give you some tips. For example, the first and the most important aspect is that it should be, the project should be finished in the sense that it should exist something. You have to first you should have a project, maybe not working at the 100%, but something should exist. And you have to search for other similar projects. And the study of the state of the art of the literature, you have to compare your project to the literature. And in order to transform your project into a scientific paper, your project should add something to the existing literature. Otherwise, it's not research, because your paper should be, you should write a scientific research paper. And you, to do this, you should search for similar papers and at least their introduction or and what the papers, the other papers do. Then practically, you can focus on your project idea. You have to write just a sentence with summarizes your project. And it's this very difficult to write a sentence which summarizes your project. Then you can enlarge this sentence, maybe by writing 2, 3, 4 sentences, and then you can write the rest of the paper. Writing skills are not simple, but today there are many tools that help you to write a piece of paper. There are the so famous AI assistants, which can be used to write parts of the paper for you, for example. And obviously, I have simplified the process, but the idea is this one. But then you have to also to choose your journal or conference where to submit. And my suggestion is to not pretend to get accepted at the first time. But it's important to read the reviewers' feedback, because they give some interesting feedbacks. Every paper is read by at least 2, 3, 4 reviewers who give feedback for your paper. And thanks to their feedback, you can improve your work, your project. Maybe they have thought to something that for you it was not, you didn't imagine something, and so they can help you to improve your work. Obviously, there are other aspects, but there is not enough time to discuss about it.
Yeah, we've got a link right there in both the chat and in the comment section of LinkedIn. It'll also be available on YouTube as well. That talks about what's actually your blog post where you talk about how to do that, how to translate project into research paper. Got a question coming in here from audience. My good friend Eric Sims is asking, how is data journalism different from data storytelling?
Yes, I think that there is a difference in the target audience, because data storytelling can be done also to other, to common people, maybe to your boss, to a company. Also, a data science project can be translated into a storytelling report, for example. Data journalism instead has the purpose to write an article, a news. Yes, but although the life skill could be the same, maybe, yes.
Thank you very much. Now let's continue on here. We're talking about science, and a huge part of science, and data science being science, is reproducibility. And you've got a post where you talk about the complete workflow for machine learning. So can you walk us through this workflow, this complete workflow for machine learning that you've written about?
Firstly, I think the most difficult part is understanding the problem. And once you have understood the problem, then you can collect data about this, the data collection phase. Then you have to clean all your data with maybe filtering, normalization, standardization, and so on. And you can also use exploratory data analysis techniques to understand your data sets. And then you can perform feature engineering by selecting the interesting features for your model. And then you train your model, you choose your model, maybe you choose your models, you try different models, and you evaluate them. Finally, you have to monitor your model, and maybe you have to pay attention to the fact that your training data set may grow old. And so you have to update your data. You have continuously monitor if your model is still valid after some times. And you also mentioned reproducibility. And this is very important because in each step of the life cycle, you have to make sure that your steps are reproducible. How to perform this, how to achieve this? Firstly, you could track every changes of your code, of your data. Every change you do should be tracked. And yes, and then you have also to pay attention, for example, to the use of random seeds. For example, when you train a machine learning model, you should put a specific seed for your model. And you have to make sure that this seed should be always the same in your model. But you have to pay attention to the use of seeds because different seeds may produce different results. And this is a very important aspect. Yes.
Yeah, that a couple of interesting points there. Yeah, the point about random seeds. I think I've done that more than once where I forgot to initialize a random seed and it kept getting different results. I'm like, what is going on? But yeah, that, and then it sounds like all of this it's so much to keep track of. Like, how do you manage this workflow? Because it sounds like there's a lot for us to keep in mind and to think about when we're building a machine learning algorithm. What's your process for keeping track of all this?
Yes, I think that in general, yeah, I do all the stuff manually because I am a researcher and I don't build deployed models. I build prototypes. And my data sets are small and I can do this stuff manually. But there are different, many frameworks, many tools that you can use. For example, I think that a very good tool that I have discovered just recently is Comet, because Comet permits you to track all your experiments or all the changes that you do to your model without rewriting again and again the same code, maybe with a little change. And I really like Comet, and I'm using it also for my tests. And I suggest you to all the audience to try it because it's very useful.
Yeah, I definitely agree. Comet's a great platform to use. So thank you for so much for sharing that. So do you have a framework for identifying a good model? So you're working on a research problem, you've got a fixed data set that you're working with. How do you know that the model that you've built is good? How do you know that there isn't a better model out there that can represent what you're trying to model better? What's your process for thinking through that?
Yes, I think there are the main. First, you have to, as you have already said before, you have to compare your model with a baseline model. If your model performs worse than the baseline model, maybe it's not good. Then you should calculate some evaluation metrics, which depend on the type of problem that you are solving. For example, if you are solving a classification problem, you should focus on some metrics such as precision, recall, accuracy, and so on. And for other models, regression, for example, you calculate other metrics. I think that there is not a perfect model. You have to test if in practice your model is good. For example, recently I calculated a model. I built a model for ship route prediction, which should predict the next position of a ship on a grid. And I calculated this model, the performance of this model, and it reached about 84% of accuracy. And also precision, recall, all the stuff was perfect. Then I calculated a similar model, which didn't have only a feature in common, which was a time-dependent feature, an input feature, and then it performed worse, about 60% of accuracy, I don't remember. But when I went to test in practice my model, the second one was better. I am still wondering why this happened, and I'm investigating this problem, but it may happen. Maybe that feature, time dependent, was very particular and didn't work in my case. And my suggestion is to pay attention to time-dependent features because they are very tricky and challenging. So pay attention to this.
It's a very interesting use case, trying to predict the location of a ship on a grid as it's moving through time. When you approach a problem like that, sounds like a challenging problem to work on. How do you think about where to start? Like, how do you even think about how should you be modeling this? Like, I guess the question I'm really trying to ask is like, how do you map algorithm or model strategy to a problem type?
To a strategy, this is a very difficult, question to answer. Yes.
Yeah.
It's not simple. Yes.
So for this problem, because maybe I don't know, like an entry point for some type of model to start out with, I don't know, regression or something. How do you think through that? How do you think through where you should start? Is it all about understanding the problem and understanding the data and then trying to map the appropriate algorithm to it? I guess just trying to get inside of your head to understand how you think through problems.
Yes, instead it was a multi-class classification problem because you had of all the possible positions of the ship in the sea, and you had to predict for each cell of the grid, which is the probability of the ship to be in that cell. And we have model that has a multi-class classification problem, but maybe the best solution should be a deterministic algorithm which takes the speed and then calculates the next position. But this approach does considerate the ground. And so we moved to a machine learning approach. And we are still fighting with this problem.
Yeah, it definitely sounds like an interesting and challenging problem, and one that I imagine requires a lot of experimentation. So in the workflow you described to us for machine learning, where in this workflow have you noticed the most experimentation tend to occur?
Yes, I think the most difficult task in experimentation is understanding the problem, because maybe especially maybe in the industry field, you don't know exactly what stakeholders want. And understand the first step is very difficult, because if you miss the first step, then all the process takes a wrong way. Then I think that another difficult task is data cleaning, because it's tedious. You have to clean, you understand your data, what type of problems your data have. Maybe you need to collect other data which enrich your data. And so this part is very difficult. For the modeling part, when you have to try different machine learning or deep learning models, in this case, you can use existing tools which do the job for you. And for this, maybe this task is not complicated as the previous one. I think personally that the most interesting part is the final part when you have to build the report with data, to build the visualizations with data, and because this is a most journalistic part, we can say. Yes.
Thank you very much for sharing that insight with us. And a comment coming in from an audience member on LinkedIn, saying that for a problem that you're describing, like the location of ship problem, maybe look into using a Kalman filter or a Kalman filtering method. So that's pretty interesting. So I'm not sure if you tried that or not, but maybe that's something to take to the workbench and experiment with, the Kalman filtering. So you wrote a piece on Medium. I thought it was a really, really great piece about your experience using Comet. So talk to us about how has Comet helped you in your machine learning model building process. I guess maybe compare and contrast, like maybe before Comet, what was your life like? And then after Comet, what was your life like?
Yes, I have to admit, I discovered the Comet recently, and I really like it because it helps me very much in my experiments, especially, as already said, in the reproducibility of the experiments. I can build many experiments with the same code. I can change only some parameters, and the Comet for me, I really like it. Before Comet, I did all the things manually. I built my graphs and my report manually. Through Comet, it's simpler. I suggest you to try it. I have only recently discovered also that Comet provides also an interesting thing, that the next interesting feature, which can be used to build different experiments for your model, to tune the parameters of your model. It's very interesting. I'm studying, and I don't know everything about Comet, but I like to learn it. And so stay tuned for in my blog. You will learn other article on Comet, because I really like it.
Yeah, thank you for continuing to write such awesome pieces. I found them to be really helpful. Both all the pieces that you write are providing advice and guidance on how to think through problems, as well as advice on how to learn stuff. One great post you wrote was about overfitting, and I was wondering, have you been able to use Comet to help you build models that don't overfit? Maybe for those who are listening, maybe aren't aware of the problem of overfitting, maybe give us like a high level overview of overfitting and how you've been able to build models that don't overfit, and maybe how Comet has helped with that.
Yes, your Comet, as I have said before, provides a feature which is the optimizer, which can be used to avoid overfitting, because there are many techniques to avoid overfitting. One of them is the tuning of hyperparameters. And Comet provides this feature, which can be used to test the different models, or the same model, sorry, with different parameters, and so discover which is the best model for you. I really like the Comet interface, because it's very simple. You make your experiments with all with different parameters, and then in just one table you can see all the results for all the experiments, and then you can choose the best model for you. I think it's very interesting. Yes.
Thank you so much for sharing that insight with us. So, data science and machine learning, it can be very frustrating to learn. It's a lot to learn. It's quite challenging, a lot to keep in your head all at the same time. I'm still learning every day, and been I've been in this for a while. I was wondering if you could share some tips with us on how to manage the challenging learning process in data science.
Yes, it's not simple. I think that the first and most important thing is that you cannot learn everything. You have to focus on something and you have to deepen and learn about that topic. You can't imagine to learn all the data science world or the machine learning world. This is the first tip. Secondly, you should keep calm because you have to study. You can't. You have to study. If you want to build a good model, you want to become successful in data, successful data scientist, you have to study. How to study? There are different techniques. You can take a book. You can read a blog article or many blog articles. But my suggestion is, and this is the thing that I use, is to write what you learn. Because when you have to focus your attention in what you have learned, and if you haven't learned something, you are not able to write it. And this is very important, I think, also writing. And then there are other things that you can, other tips that you can follow. For example, you also have to take a break. Don't study 20 hours per day, but take a break because your mind opens. And so maybe a problem that before seemed very huge then becomes small. But the practice, I think that practice is one of the most important thing in machine learning, data science learning.
Yeah, absolutely agree. There is so much to learn, and it can feel frustrating. There's so much, and you're like, oh my God, I don't have enough hours in the day. I don't have enough time. But then you realize that there's actually no rush for you to learn everything. You don't have to know everything by the end of next Tuesday. You can still take your time learning stuff and really enjoy the process. I like this point you made about just taking a break. I've found that those situations where I would just work continuously and study continuously and not take breaks, not get up to walk, not go to the gym, not get up to move around or clear my head, things just feel like they're stuck in here, like my thoughts don't flow quite well. But after getting away for a while, after moving around and doing something, it feels less like a pinball bouncing around erratically in my head and more just like calm, and it's easier. With respect to writing, do you have any tips for people who maybe want to get started with writing, but maybe they're not confident enough to share their ideas with the world?
But I think that we are a community, and we help each other. So I think it's important to share the knowledge among people. We are a humanity which moves together, and so I think that it's important to share what we learn. It's our little piece in the sea, but together we will do the sea.
Thank you so much. That was very beautifully put. Really appreciate that. So let's go ahead and open up for some Q&A here. If anybody has any questions here for Angelica, please go ahead, let us know. You could drop it right there in the chat, or if you'd like to come on stage, so to speak, let me know. I'll go ahead and bring you up, both for people listening in on LinkedIn and for if you're joining us on YouTube or on the Zoom room here. Let us know if you got questions. I'll keep talking until I kill enough time and see a question come in. So another kind of question for you, Angelica, we'll give folks a second to come up with questions. But when you're working on research and academia, how do you come up with project ideas? Is it just whatever it is that you are currently interested in exploring, or does like somebody from university come and say, hey, I've got this problem, can you work on it? What's that process like?
Yes, we work. We usually participate to other projects, and maybe if we have some ideas, we can also investigate this idea. In particular, I am a researcher at the Institute of Informatics and Telematics of the National Research Council in Italy, and I'm also external professor at the University of Pisa. But my main research department is this one, and is the Institute of Informatics and Telematics. But we can, if we have an idea, we can investigate it and maybe start a project also with the industries, companies or other institutions. Yes, there is not a limit.
So thank you very much for sharing that. So question coming in here from the audience on LinkedIn: is fact checking also important for your role as a data journalist outside of your modeling or insights duties?
Yes, it's very important. I have recently read an interesting book from Joseph Berengers. And in this book, the author said that in data journalism, usually there are some problems of bias, because maybe some news report real data, but they are partial. There are not the totality of data, but some data are extracted from the total data sets to drive the reader to make some conclusions. And first, you have to check facts, and the data could help you to check your facts. And secondly, you have to pay attention to not extract only data that you want. You have to be partial. You have to be impartial. You have to report data as they are, and you cannot modify them.
Thank you very much. Great question coming in for the audience. We'll open it up maybe for another question or two. If anybody has questions, please do let us know. So any tips for people in academia who are looking to maybe move into industry? Do you have any tips for those type of folks?
People moving from industry to academia, I guess.
The other way around, moving from academia to industry. Do you find that to be a bit of a challenge?
Yes, I think that the difference between academia and industry is in deployment, because usually in academia the deployment part is missing. In the research in the research field we have new ideas, so we test them, but we don't product. We only build a prototype, and so maybe they should study some techniques for model deployment. Maybe
that's a good point. I guess in academia, deployment means writing the paper and getting published. So thank you very much for taking time out of your schedule, Angelica, for talking to us about the amazing work that you've done about data journalism and sharing your knowledge. If you guys haven't already, look Angelica up on Medium. We will have links to her blog both on the YouTube and in the email. Angelica, once again, thank you so much for being here.
You are welcome. It was a pleasure for me to be here today with you, and congratulations for your work.
Thank you so much. I appreciate that. Guys, stay tuned. Next week, we've got another amazing session. We are going to be speaking on a panel type of discussion next week. We've got Dr. Abe Gong, CEO and co-founder of Great Expectations. He's going to be in the building. We got Jimmy joining us Jimmy Whitaker joining us from Pachyderm. We got our good friend and community contributor, Matt Blaza, joining us as well. Next week, we're going to talk all about data. Can't do machine learning without data. So we're going to talk about the importance of understanding, validating, versioning data. How do we go from the real world and ensure that the data that we're capturing in the real world is an accurate reflection of the real world, so that when it hits our model, we can come up with great predictions. So stay tuned for that. I'm excited for that. It's going to be a great panel discussion. Same time, next week, next Wednesday, 10 a.m. Central Time. And on top of that, we've got amazing supplemental material that'll be coming along with this course that you can check out. My colleagues, Michael and Drew, have been hard at work taking what we've been discussing and putting it into action so you could see exactly what it looks like. Everything's going to be available on the Comet YouTube channel. If you haven't already subscribed to the Comet YouTube channel, make sure you subscribe. If you're watching on YouTube right now, hit that subscribe button, smash that like, hit that bell notification. Don't miss out on anything that we're sending. It's going to be great. I'm looking forward to it, man. Next week's going to be awesome. Thanks again to Angelica for joining us. And thank you guys for being here with us. Take care. Have a good rest of the day. And remember, my friends, you got one life on this planet. Why not try to do something big? Cheers, everyone.